In this problem, we're told a 37 kilogram crate is placed on an inclined ramp. When the angle the ramp makes with the horizontal is increased to 23 degrees, the crate begins to slide downward. A. What is the coefficient of static friction between the crate and the ramp? B. At what angle does the crate begin to slide if the mass is doubled? So you want to draw what's going on here. So we have this crate. It's going to be on a 23 degree incline, and we know it's going to have a mass of 37 kilograms. And so what we're trying to do for A is find the coefficient of static friction between the crate and the ramp. So we're trying to find mu sub s, which is the coefficient of static friction. So that's what we're trying to find. And the first thing you always want to do for these problems is to draw a free body diagram and label all the forces acting on it. So we know we always have the force, mg, which is just the weight force, going straight down. We know we're going to have the normal force going perpendicular to the incline because, right, when an object touches, it's perpendicular to it. And then we also have the force of friction going this way. So, and that's going to be because it's going to be slowing it down, and we're solving for mu sub s, so obviously there's going to be friction. And so basically these are the three forces. But what we want to do is find the x and y component of this force right here. So because these are already in the x and y axis, and when I say x and y axis, I'm talking about this being the x and then this being the y. So they're already aligned with it. And generally what you want to do is just find the x and y component of a force that's not aligned with it. So what we want to do next is just find the x and y component of this weight force. So we know the hypotenuse is mg, which is this line right here, and then this is x and y. So this is, if I'm redrawing it, right, we know this is 23 degrees because this is what the incline is at. I'm just redrawing this triangle. Opposite is going to be the x, and then this is the y. So if we want to find the x, right, this is the x component of our weight force. We know we know sine, one of the trig functions. Sine is equal to opposite over hypotenuse, and the opposite is x over mg. So solving for the x component, it's just going to be mg, right? Multiply both sides by mg. Mg times the sine of 23. That's the x component of your weight force. And then for y, you use cosine. So the cosine of 23 is equal to, a cosine is adjacent over hypotenuse, so y over mg. And then multiply both sides by mg, you get mg times the cosine of 23. So these are going to be the x and y components of your weight force. So now what we've done is we made every single force either in the x and y, unless if it wasn't already. Right, so force of friction in F sub n, this is in the x and this was already in the y, so we don't have to take the components of it. So now what we're going to do is take the sum of the forces in the x direction, which is this line right here. So we say the sum of the forces in the x is going to be equal to, and so keep in mind it's going to be equal to 0, and the reason this is because it's not moving, right? We're trying to find the coefficient of static friction, and static just means it's not moving. So 0 equals, and then what we want to do is find the forces. So along this line, what forces do we have? We have the force of friction, right, which is going opposite to the way we're going to be traveling, right? So I'm just going to say this way is negative and this way is positive. So I'm going to label this negative when we add it. So minus the force of friction, and then it's going to be plus, and we have the x component of the weight force going in this direction. So it's going to be positive. We have to add, right? So the x component we add is going to be positive. And so the x is just mg times the sine of 23. So mg times the sine of 23. And so what we know, if we add this to the other side, the force of friction is essentially just equal to mg times the sine of 23. And this makes sense, right? Because we only have this force, and in order for it not to move, they have to be equal. So the force of friction equals mg times the sine of 23. But what do we know about the force of friction? We know the force of friction is equal to mu sub s times f sub n. And so what we can do is plug this in, mu sub s times f sub n, which equals mg times the sine of 23. And so if we want to solve for mu sub s, we just have to divide both sides by f sub n. Because keep in mind what we're solving for is mu sub s. So now what we have to do is find f sub n if we want to solve. So what is the normal force going to be equal to? So the way we find it is by taking the sum of the forces in the y instead of the x this time. So the sum of the forces in the y is going to be again equal to 0 because we're not moving in that direction. So 0 equals, and then we add the forces in the y. If it's going upwards, we say it's positive. If it's going downwards, it's negative. So in the y, we only have two forces. We have the normal force, which is going upwards, so it's positive, and then minus the y component of our gravity because it's going downwards. So the y component of the force, or the weight force, is mg times the sine of 23. Or sorry, not sine, it's cosine. Mg times the cosine of 23. So mg times the cosine of 23, and this basically just tells us the normal force, if we add this to the other side, is equal to mg times the cosine of 23. So now we have the normal force, and so if we want to solve for mu sub s, or the coefficient of static friction, it's just mg times the sine of 23. And then if we divide by f sub n, which is mg times the cosine of 23, notice what's going to happen. Mg can cancel, so it's really just the sine of 23 divided by the cosine of 23. And when you do that, you're going to get mu sub s is equal to 0.42447. And so you can round however you want. You can just say the coefficient of static friction is equal to about 0.42. And so keep in mind it's unitless. There's no units on static friction. So 0.42, that's going to be the coefficient of static friction, or your answer to A. Now let's move on to B. So for B, what we're trying to do is find at what angle does the crate begin to slide if the mass is doubled. So look at this problem right here. So when we solved it, notice what happened. The mass is actually canceled. So even though the mass is going to be doubled, the angle or the coefficient of static friction doesn't actually change at all. So essentially what that means is the mass is irrelevant. So it actually doesn't matter the mass for it to slide. So it doesn't actually matter. So the angle is just going to be the exact same as this one. So the angle for B is just going to be 23 degrees because the mass actually doesn't matter, just because it cancels out. So your answer for B is just going to be 23 degrees. And yeah, so B is 23 degrees. This is going to be 0.42. And yeah, hopefully you found this useful.